All right, so 8.2 is going to talk about glycolysis. Remember, glycolysis is the first step within cellular respiration. Remember, if you break down words, it's going to help us later on if you come across a word that we don't know. Glyco means sugar, lysis means to break. So, this is the first process or the first step that's going to start breaking down sugar. This occurs in the cytoplasm, and almost every organism on Earth is going to go through cytoplasm. And this is kind of key for this, or this is evidence for this process or this step evolving very early on in life. So, billions and billions of years ago. All organisms have a cytoplasm. All organisms have glycolysis. I should say almost all organisms have glycolysis. That means it's going to have evolved again very, very early on. Some of the first organisms had this process. Later on, we see the Krebs cycle and the electron transport chain evolve specifically in the mitochondria, which is going to occur in eukaryotic cells more specifically. Within glycolysis, we're going to have a breakdown of a glucose molecule. Remember, we make glucose in photosynthesis. I have the carbons here. Glucose is a 6-carbon molecule. I would also know the chemical formula for glucose. So glucose is C6H12O6. I would definitely know that just from last chapter and this chapter and your 9th and 10th grade biology class. I just know that. It's going to break them down into 2 pyruvate molecules. You can see pyruvate is you can see here 3 carbons. We're going to see pyruvate in this step and the next step because the products of this step are the reactants of the next step. Now, I love using this diagram for the glycolysis because it really kind of simplifies it. Glycolysis can look really complicated. There's, I think it's a 10-step process, 10 or 11, depending on how you look at it. There's a lot of enzymes. There's a lot of reactions going on here. There's a lot of molecules. And yes, in like your last year of biology or last year of college, I had to memorize every single one of these steps and enzymes. Here's the great thing is you don't have to memorize all those. I only want you to memorize a couple different molecules here. So you can see at the top here, we're only focusing on the carbons in glucose. Glucose, again, has 6 carbons. So there are 2 steps here that we're going to talk about. This first step is the energy investment step. This is where we need to input energy or input ATP and use up ATP in the first couple steps. Our second step is the energy harvesting step. This is where we're going to get energy or get ATP in return. So you can see glucose here is going to be phosphorylated by 2 ATP. You can see here it's still 6 carbons, but it has 2 phosphate groups at the end. I really don't care if you learn the fructose 1,6-biphosphate. I'm not really interested in that because there's a lot of molecules here, but I wouldn't understand glucose is phosphorylated first by using up 2 ATP. Think about this 2 ATP as like starting a business. You can't just start a business and start instantly making money. You need to invest money. You need to put in money. You need to spend money on like buying, like let's say you're making a hair salon or you're going to start a hair salon. You have to buy, equipment. You have to buy styling gels and scissors. You have to put a lot of money into the business first before you can make any money out. You also have to pay your employees, and you also have to like rent a spot. So you have to put a lot of money down to then start making money later on in the future. So think of this portion here as, hey, we're going to invest some ATP in order so we can get ATP. Now, fructose 1,6-biphosphate will break down into 2 molecules. What I want you to know from this reaction, again, there's a couple different reactions here, is that it's going to produce 2 G3P molecules. We saw those G3P molecules in photosynthesis, but understand that DHAP, it will actually first break down to DHAP and this G3P, but then DHAP is changed and converted into another G3P. So just understand that this 6-carbon molecule is going to break down into 2 G3Ps. That's the energy investment stage. Sorry. So after the energy investment stage, we have 2 G3Ps. These guys are going to go through a couple of different reactions. They are going to each produce 2 ATP and 1 NADH. So that means we have to times everything here by 2. So our total products of the energy harvesting step are 2 NADHs and 4 ATP. The net total for this will be 2 ATP because we already used up, so we're minus 2 ATP here. We're producing 4 in total here. So we're only really making 2 ATP here. Another product is that we're making two pyruvates. These pyruvate molecules are going to go into the next step. I went over these two steps in pretty good detail in the last slide, so I'm just going to quickly go through here. Remember, in the energy investment step, again, you have to use 2 ATP to phosphorylate glucose. Glucose then splits into two G3P molecules. I don't even mention the DHAP here. It's really not important. I want you to know that glucose is going to make its way down to make two G3P molecules, which are 3 carbons. That's the energy investment step. This is the energy harvesting step. Again, this is per pyruvate. Remember that the NADs are going to become NADHs by being reduced. They're going to take on electrons and a hydrogen ion and become NADH. These guys are those electron carriers we talked about. We produce 2 ATP molecules per G3P. That means, again, we have to times everything by 2. So we make 2 of these guys and 4 of these guys. All right, so some major points here with glycolysis. We're going to input a 6-carbon glucose molecule. We also have to input 2 ATP molecules here for this process to occur. What we're going to get out is 2 pyruvates, 2 NADHs, 4 ATP, but we have to subtract 2 ATP because we have to, it's one of those, the idea is you have to spend money to make money. So we're only going to get a net total of 2 ATP. In the long run, this isn't a lot of ATP. You use millions of ATP per second. You need a lot more ATP. So this isn't really a lot of ATP. All right, this is probably one of the more confusing things about cellular respiration. Within cellular respiration, we have something called substrate level phosphorylation, and we have oxidative phosphorylation. So what we're going to talk about here is how ATP is specifically produced. So in glycolysis and the Krebs cycle, we have substrate level phosphorylation. What happens with substrate level phosphorylation is this enzyme is going to take a phosphate group off of a substrate and add it to an ADP molecule, making it ATP. So the whole process here is an enzyme takes a phosphate group away from a substrate. That's how ATP is produced. We're going to see oxidative phosphorylation later on, totally different. Again, enzymes take a phosphate group from a substrate and add it to an ADP molecule, making it ATP. This is just a one type of way ATP is produced, and this only occurs in glycolysis and the Krebs cycle. It only accounts for around 10% of the ATP produced per glucose in cellular respiration.